So today we will be talking about one more topic in optimization. It's very fundamental topic. So it talks about convergence results. So we know from optimization when we are doing iterative methods to find the local minima that our next iteration, that is our k plus 1th iteration, should be equal to our previous iteration minus alpha times del of f of xk. So this is the gradient and it comes from descent direction. That we say that the direction of the descent should be minus times in the opposite direction of the descent. If this is true, then we can see that we are actually approaching the local minima, and your next iterate will actually give you the result where your function value is less than the previous one. So you will eventually reach the local minima. And alpha here is the step size. Now we will go on to see a theorem which talks about the step size and a condition related to it. So we have, let f be a continuously differentiable function with a Lipschitz gradient with with L. So your Lipschitz gradient means there exists a parameter L such that f of y, the gradient of f of y minus the gradient of f at x, is less or equal to Lipschitz times y minus x for all y comma x. So if this condition is true, that your function is continuously differentiable and it has a Lipschitz gradient, which means that this condition is true, then we'll say let alpha, the step size, be between 0 and 2 by L, and the minima of your function is such that minima of f of x is greater than minus infinity. So the minima of your function is not at minus infinity, it's greater than that. Then we'll have this result, that limit k goes to infinity, norm of the gradient of f at xk is equal to 0. It means that when you do the iterations, at your kth iteration, the gradient's norm should be equal to 0 when k goes to infinity. So when you do a lot of iterations such that your number of iterations goes to infinity, then you will be eventually assured convergence. Let's look at the proof of this theorem. So I'll say, from descent lemma that we have covered in the previous video, we have a result that f of y is less or equal to f of x plus del f of x transpose y minus x plus Lipschitz constant by 2 times norm of y minus x whole square. So this comes from descent lemma. Now here I will use a thing. I'll say that let my y be equal to x of k plus 1 and my x be equal to xk. Now let's see what happens. So f of xk plus 1 would be less or equal to f of xk, putting these values in descent lemma, plus the gradient of f at xk transpose y. So instead of y minus x, we'll have x of k plus 1 minus x k plus Lipschitz constant by 2, the norm of xk plus 1 minus xk का स्क्वायर.